what makes beings like us be conscious is more, I do regard it as a question of physics in a sense, because my view is that it depends upon something in physics which we do not understand as yet. I mean, the way around I look at it is that the universe is there, and in certain small parts of the universe, probably rather rare, things arrive, which we call beings and which we call conscious beings, in which the material of the universe is put together in such a way that a feature of the universe which is potentially there is somehow realized, but normally not. So I'm more on the side of saying matter is primary, but I don't like to put it that way, because matter, in a certain sense, is not the whole of the way physics is described. You say you have, I mean, is light matter? You don't call light matter normally. Are photons matter? I mean, massive particles tend to be referred to as matter, and are they more important primarily than things like gravitational waves or something? I mean, it's not very clear. The notion of matter is not very well defined in that sense, but it's better defined than conscious experience, because we don't really know that much about that. We have it, but somehow what makes beings like us be conscious is more, I do regard it as a question of physics in a sense, because my view is that it depends upon something in physics which we do not understand as yet. We do understand the problem, that is to say, it's not something, with no connection with the way the physical world operates. In my view, and I'm giving a very specific view of my own here, that current physics has a huge gap in it. And the huge gap, see, people often say, well, quantum mechanics is the best theory we ever had, and they hesitate to mention that it's actually not such a good theory because it's self-inconsistent. When I say self-inconsistent, I mean, well, say the primary equation of quantum mechanics can be phrased as being the Schrödinger equation. And the Schrödinger equation tells you you've got the state of the system, then the equation tells you how that state evolves in time. The only trouble is it doesn't. It evolves in time for a while until it does what's called, somebody makes a measurement. What does that mean? Well, they wheel out of the cupboard some machine which makes a measurement. Well, that machine is made out of the same material as everything else, and so why doesn't that evolve according to the Schrödinger equation? I mean, Schrödinger clearly understood this because of his cat. I mean, people say, oh, well, we could make a Schrödinger's cat if we were clever enough and so on. That wasn't the point of Schrödinger's talking about his cat. The point he was talking about was, look, when I say mine, I mean Schrödinger's equation, he was saying, in a sense, my equation doesn't describe the way the world behaves. If you had a cat and tried to do this experiment, you get to this absurdity, namely a cat which is dead and alive at the same time. Well, a load of nonsense. A cat wouldn't be dead and alive at the same time. Something goes on in the physical world which isn't in accordance with the Schrödinger equation. So he was very clear on that point, although people often misunderstand him, I think. I thought he was very clear on that point. And he and Einstein and even Dirac, rather surprisingly, were of the view that quantum theory needs some attention, that it's not, well, they say it's not a complete theory. I would say it's even worse than that in the sense that it's not even a self-consistent theory, because the theory says the system should evolve unitarily, in other words, according to the Schrödinger equation. But the world doesn't behave that way. It suddenly turns itself into probabilities and things. It's not that state, it's the probability of different states. And how on earth does it do that? The Schrödinger equation doesn't do that, as Schrödinger well knew. So there's another part of the theory, which is referred to sometimes as the collapse of the wave function, or whatever you say. It means that the quantum state does not describe the way the world behaves. At certain stages in its existence, it turns into a probability of different alternatives. And the puzzle is, why does it do that? When does it do that? What is the theory underlying a generalization of quantum mechanics which contains that collapse process?